1942, the number of the smallest unoccupied chair. So for this problem, I think we first need to understand the problem. Although the description is very long, but it should not be so difficult to understand. Basically, the problem is based on the description. It's like a simulation problem. We have to simulate everything about the description, and we have to check the examples one by one. Maybe we can find how to simulate the problem by using some data structure. Maybe we can solve the problem. As the n is 10 to the power 4, this means we cannot solve it by using O(n) squared. Basically, maybe we can solve it by n log n time or O(n) time. It should be okay. Now let's just go to the problem. So there is a party where n friends numbered from 0 to n minus 1. So the friend is called from 0 to n minus 1. Yeah. So each of the number, it means it is just a friend. Yeah. So all the friends are gonna be from 0 to n minus 1. So that's gonna be all the friends gonna be attend to the party. So there's an infinite number of chairs in this party, and there are numbered from 0 to infinity. So the chairs is just coming from 0 to infinity, and we don't know how many chairs. So when a friend arrives at the party, they sit on the unoccupied chair with the smallest number. So the chair number is just coming from 0, like 1, 2, until infinity. Yeah. So this is gonna be the chair number, and another number is the friend's number. It also gonna coming from 0 to n minus 1, and the chair number is also coming from 0 to n minus 1. Let me put an n minus 1 here. Yeah. Now we just check this example. If chair 0, 1, and 5 are occupied, for example, this is the 0, 1, 2, 3, 4, and 5. Yeah. So if this is occupied, and if this 5 is occupied, if this 1 is occupied, so for the next friend when it comes, I don't know which friend it is, but for example, it is a friend maybe 3. Maybe the friend 3 comes, so which chair this guy gonna take? Definitely it's gonna be this number 2, because this is the first chair from the left to right, which is unoccupied. Definitely this guy 3 will take the chair number, which is 2. So a lot of numbers, maybe it is confusing. Yeah, but in programming, basically we just use numbers for simplicity to represent the problems. So the friend's number is coming from 0 to n minus 1, and the seat's number is also coming from 0 to n minus 1. And for this friend 3, when it comes, because 0 and 1 is occupied, so this friend 3 will take the seat number 2 here. So when a friend leaves this party, their chair becomes unoccupied at the moment they leave. If another friend arrives at the same time, they can sit in that chair. So there's a sequence. So for example, at one moment, this guy at seat 1, maybe this guy is number 2. Yeah, it doesn't matter. This guy at seat 1 will leave, but at the same time, another person arrives. So this means, so this means first of all, this chair will be occupied, and next, it will be occupied by another guy. Maybe this guy is number 4. Yeah, because all friend is named by a number. Maybe this guy will occupied at this position. So we are giving a 0 index to the integer array times. So where times I, it means arrival I and leaving I. So indicating the arrive and leaving times of the ith person, ith friend respectively. So this is the arrive time, and this number 4 is the leave time. And we are also giving a target friend. So for the target friend, we are giving a number. Because all the friend number is from 0 to n minus 1, so we are just giving a random target friend number. It is coming from 0 to n minus 1. And also all the arriving time are distinct. So this is the arriving time. So all those arriving time is distinct. Maybe we can use a sort to sort the arriving time, because they are all distinct. Yeah. So if they are not distinct, for example, we have 1, 4, maybe we have a 1, 3. Yeah, it will have some issues, because at the time at this time 1, yeah, there at some time, maybe at some time arriving time is 1. We have a person arriving time 1, we have another person. This gonna make the problem really difficult because at this time there will be 2 persons in this seat. But according to our problem, one seat is gonna be only 1 person. If there are 2 persons, it's not the problem. That is why all the numbers are gonna be distinct. All the arrive time is distinct. Yeah, but for the leaving time, it doesn't matter. Maybe at one leaving time there are 2 person leaves. Yeah, but for the arriving time it is distinct. It means for each of the time there will be only 1 person take a seat, and this seat will be unoccupied. Yeah, but for the leaving time it is okay. So we're gonna return the chair number that the friend numbered the target friend will sit on. So according to my explanation, yeah, so for example, this friend, the target friend is 1. We just need to find that person which the number is 1 will occupy a seat. Maybe we're gonna check the available seat, maybe 1 or maybe 2. Yeah. Now let's just use use the first example to explain what does it mean. So for friend 0, first of all, we're gonna have a friend 0 because the friend is coming from the 0 to 2. Yeah. So for the first one, actually this is arriving time and leaving time. It is 1 and 4, but the friend, it is called 0. So the friend 0 arrives at time 1 and sits on chair 0. So this is chair 0, and the first friend comes, and this guy with arriving time and leaving time will sit on the sits on the chair 0, and then for the next one it will be friend 1. So the friend 1 arrives at time 2, so it will arrive at the next time and sits on chair 1 because 0 is occupied. So this is the chair 1, and this will be the next friend. It's gonna be 2 and 3. Yeah, 2 and 3 is the arriving time and leaving time. And for the next time, friend 1 leaves at time 3. Yeah, so before the next friend 2 comes, so the friend 1 gonna leave because it is a time 3. If it is a time 3, this friend will leave first. So the friend 1 leaves at times 3. Yeah, and the chair 1 becomes empty. So it will be like this. So the chair will become empty, and this friend leaves. And for the next, friend 0 leaves at time 4, and chair 0 become empty because while we are arriving at this time 4, so this is the starting time of friend 2, but at time 4 there's another friend 0 will leave first, so this will be empty again. And friend 2 arrives at time 4 and sits on chair 0, so the friend 2, it means this person arriving time and leaving time, it is friend 2 will occupy the seat 0. Yeah, so he will sit on the chair 0. Since friend 1 sit on chair 1, so we're gonna return a 1. Yeah, so according to all the simulation, the friend 1, so here is the friend 1 arrives at time 2 and sit on chair 1. Actually it is here, so we just need to return a 1. So we don't need to take care of all others, but for our final return we only need to take care of that friend 1 because this is the target friend. If the friend 1 arrives at time 2, definitely we're gonna return this 1 because this chair 1 is available. Now let's just check maybe the second example. So for the second example, it is just the same idea. So the friend 1 arrives at time 1. Why? Yeah, so the friend 1, it means it is this arriving time and leaving time. It will be 1 and 5. So this is same, so we can solve this problem by sorting according to the arriving time. As we can see from the example, so the friend 1 arrives at time 1. So this is friend 1 arrives at time 1 and sits on chair 0. So this is chair 0. So this is the arriving time and leaving time, and we're gonna also prepare an index. It means which friend it is. So for this one, the index is gonna be 1. Yeah. So this means friend 1 occupied the seat 0, and then friend 2 arrives at time 2 and sits on chair 1. So this is chair 1, and inside it's gonna be friend 2. So the friend 2 gonna be arriving time 2, leaving time 6, and friend number which is 2. Yeah. And then the friend 0 arrives at time 3 and sits on chair 2. Yeah, so this is chair 2 because 0 and 1 is occupied, and now we're gonna have this friend 0. So basically inside it is 3, 10, and 0. Yeah, so it is 0, and it will occupy the seat number 2, and this is also occupied. And then for the next time, friend 1, yeah, but what are we gonna return? We're gonna return the target friend. So this is the target friend 0, arrives at time 3 and will sit on chair 2, so we're gonna return a chair 2. Yeah, but for finishing all the simulations, we just need to finish all other. Actually from here we can just return a 2 because this is okay for the friend 0 equal to the target friend, y equal to the target friend, so we're gonna directly return the chair which is available. It's gonna be 2. Yeah. And let's just finish the simulation. So the friend 1 leaves at time 5. Yeah. So the friend 1, this is the leaving time. So at time 5, the friend 1 leaves, and it's gonna become empty. Yeah. So this one gonna become empty. And friend 2 leaves at time 6. So the yeah. So this is a friend 2 actually. So this is friend 2. This number 2 here is friend 2. So if friend 2 leaves and the seat 1 become empty, and this is a friend 0. Friend 0 leaves. So when it leaves, it according to yeah. So when it leaves, it according to the leave time. So the leave time is 10. So when it goes to time 10, the chair 2 will become empty again. Yeah. So this is our final. If this is an empty array, so this is our final empty array. It will also become all available. It means inside of the array 0, 1, and 2 is available. Yeah, because definitely all the person gonna leave. We have a leave time, but actually we don't need to execute all those lines. Only we need to return this 2. It is okay. So now let's just simulate this problem by using a priority queue. Actually we need to use 2 queues. One is empty, so it means all the available seats. Let's just name it empty seats or empty chair. And we also need another heap. So the empty heap is going to be a min heap. It means all the empty chairs which is available, we're going to put it inside the empty heap. And another heap is used heap. This heap, it means if this chair is occupied, I want to put it inside the used heap. And inside the used heap, basically, it will be a leaving time, because I need to know which time I'm gonna leave. If I leave it, I would to put it inside the empty heap. Yeah. So it's gonna be a leave time and the friend ID basically. So I'm gonna use the index. So it's gonna be a leave time and index, because the index is the ID for the friend. Yeah. So let me just start the program. So we're gonna prepare n gonna be length of the times, and for the times array, as we need to put the index inside the times array, because the index is which friend it is, because we need to use the index to represent the friend. So the times array gonna be expanded to it's gonna be expanded to arrive time and leave time and the index. So for I arrive and leave, enumerate the times array. So the times array is going to be expanded to arrive time, leave time, and index, because I need to use this index to represent which person, which friend it is. Yeah, so basically this I is the friend, And now I need to sort it according to the arriving time. Yeah, because according to the simulation, as we can see that the arriving time will always come the first, like the time 1, 2, 3. Now, so the times array is sorted, and for the empty array, let's put all the available seeds inside. It's going to be a list of rings from n. Basically, it is 0 to n minus 1. So from the beginning, all the seeds are available. So we're going to put it inside an empty array. And now we're going to turn this empty array to a heap. Yeah. So we can use the heapify this empty array. Yeah, because we always want to take the smallest chair number. So if there are two chairs, maybe it is 0 and 1. So this is a chair number. We always want to take the 0 first because this is the smallest number. So that is why we're going to turn this empty to a heap, to a min heap. And this used array is also a min heap. Now we can check the arrive time, leave time, and the index inside the times array. And we can check that. Yeah, but before we check that, we need to calculate all the leave time. So if all the leave time inside the used array is less than or equal to the arrive time, basically it means inside the used array we need to pop it out and put it inside the empty array. Yeah, put it. We're gonna pop it out from the used heap and put it inside the empty heap. Basically, those are two heaps. This is the min heap used. Another heap is the min heap empty. So the used means the chair is occupied. So we're gonna use a while loop to check if there's something inside the used heap and the used 0 and 0. Basically, it means the leaving time. So the smallest leaving time, if this is less than or equal to the current arrive time. So this means those leave time. So this means those chairs should be cleared first and put it inside the empty heap. Yeah. So let's pop it out. So we need to pop it out from the used heap. Yeah. So from the used heap, we're gonna have leave time, but currently this leave time it doesn't matter because we're only considering the index. So we're gonna pop it from the index. So we're gonna use a heap pop with the used heap. Yeah. So we're gonna pop out the smallest index. Basically, it means this is smallest. This is smallest chair. So this index it means the chair number. So it's gonna be the smallest chair number. So basically, it is the leaving time and the chair number inside the used heap. Yeah. So we're gonna pop out this index. Basically, it is the ID, the chair number, and we want to put this chair number inside the empty heap. So we're gonna use a heap push with empty heap, and we're gonna push the number, which is gonna be this index, or maybe we're gonna use ID. Let's just use the index maybe. Yeah. Now we put everything inside the empty heap. That means, if we want to pop out something from the empty heap, basically it's gonna be the smallest chair number. So actually, we just needed to use this chair number. We need to pop it out because, because the next person arrives, definitely it want to take this chair. Yeah, so this is arrive, leave, and this person I, and this person I will take this chair. So we're gonna first pop it out from the empty heap. So now it means this current, basically it means this number, this seat, this chair, the current chair is popped out from the empty heap. Yeah, and now we need to check this person. If this person equals to the target friend, if this is my target friend, if this person, because this I is basically a person, if this person equal to the target friend, so I can return the seat number, which is the current. Yeah. So finally, I just needed to put something inside the used array because this currently it is occupied again inside the used heap. So inside the used heap, we need to put the leaving time. So it's going to be the leave Yeah, so we're gonna push the leave time, because this leave time basically it's gonna be bigger, and this one leave time, this is leave time gonna be smaller. Yeah, we're gonna put the current leave time, and yeah, and the seat number, and the seat number is the current, because this one will be occupied again, and we're gonna put it inside the used heap. Yeah, so this is going to be the entire code for the solution. I think for such a kind of solution, it's really difficult to explain why it works. We have to, yeah, I mean, it's not so easy to understand while you are listening to the tutorial or something. You have to start coding by yourself. You have to understand why this greedy idea works, and at which time the used array will be cleared, and at which time it will be cleared, and which time we're going to put the cleared part inside the empty part, inside the empty heap. Yeah, basically the two heap is a little bit more difficult than the one heap problems. Now let me just run it to check if it works. So it's going to be a used heap. Yeah, as you can see, it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed. So the time complexity gonna be n log n. So this is the time sort, and this is the n log n time. And from here, we just loop through it, and we're gonna use a heap push or pop. So this is another n log n time. So the final time complexity gonna be n log n. That is why it's so fast. Thank you for watching. See you next time.